Hello students and welcome to the lecture on tournament selection. The 16th lecture in the lecture series for the course of Introduction to Soft Computing for Electronics and Telecommunication Engineering students of the 7th semester Goa College of Engineering. I am Ms. Purti Savadekar, the faculty in charge for this course. In the last lecture, we discussed and understood the stochastic universal sampling technique. In today's lecture, we will focus our attention on the next topic, the tournament selection technique. So let us begin. The tournament selection technique also tries to solve the problem of fitness proportionality selection. If only higher fitness individuals get selected, possibly a suboptimal peak will be reached very rapidly. We want a comparatively slower convergence towards globally optimum solution. At the outset, I would like to introduce you to a term called selection pressure. What is selection pressure? Selection pressure is the degree to which better individuals, fitter individuals are favored. The degree to which fitter individuals are favored. How much are we favoring the selection of a fitter individual? The higher the selection pressure, the more the fitter individuals are favored in selection. This selection pressure drives the genetic algorithm to improve the population fitness over succeeding generations. Higher the selection pressure, fitter are the individuals that are selected, and that is why higher is the convergence rate. That is how the convergence rate of a genetic algorithm is largely determined by the selection pressure. What is convergence rate? The speed with which we are reaching the peak, the final solution. That is called the convergence rate, the speed with which we are reaching the final solution. The fitter the individual, the faster is the movement towards the final solution. That is, faster is the convergence. Higher the selection pressure, faster the convergence. Therefore, selection pressure can be varied to obtain solutions that may be suboptimal, near optimal, or optimal. However, if the selection pressure is too low, the convergence rate also will be too slow, and the GA will unnecessarily take a long time to find the optimal solution. A long time, but to find the optimal solution. If the selection pressure is too high, then there is an increased chance of the GA prematurely converging, but to an incorrect solution, a suboptimal solution. Tournament selection provides selection pressure by holding a tournament among certain number of competitors. This number of competitors is known as the tournament size. Another term that you'll have to remember. The winner of the tournament is then inserted into a mating pool. The mating pool consists of all the tournament winners. The mating pool generally has an average fitness which is higher than the average population fitness. There is a difference. This difference in the fitnesses is because of the fitness pressure. Because of this fitness pressure, GA is driven to improvement in fitness over a number of generations. So, how do we increase the selection pressure in case of tournament selection? Here is the answer. By increasing the tournament size. What is the tournament size? The number of competitors in the tournament. If the number of competitors is high, there is a higher chance that the winner has higher fitness. compared to a tournament with smaller number of competitors. Pause the video for a minute or two and give this a thought. Let us now try to understand the tournament selection method in detail. As the name suggests, the method is inspired by tournament or a competition. So let us first understand the simplest version of the tournament where the number of competitors is 2. The tournament size is 2. Out of the n number of individuals in the population, any 2 individuals are selected at random. These are the competitors. Now a random number is selected which lies between 0 and 1. We will use this random number to declare either one of the competitors as a winner. This is where it gets interesting. How do we declare one of the competitors as a winner? On what basis? Their fitness? By now, we very well know that absolute fitness should not be the criteria. Then, of course, we will use the fitness of the individuals, but not so directly. There should be some randomness to it. That is where the random number R comes into the picture. We would want to select one competitor as the winner with some probability P and the other competitor as the winner with the probability 1 minus P. Correct? So the total probability of a winner getting selected is 1. To do this, we consider a predefined number K. We give it some value like 0.75. So K has the value 0.75. Now we compare our random number R. Is R greater than K? Is R greater than K? If yes, then the competitor with lesser fitness is declared as the winner. If R is greater than K, then competitor with lesser fitness is declared as the winner. If R is less than or equal to K, the competitor with higher fitness is declared as the winner. As you can see, the random number R is compared with 0.75. We know that there are more chances of R being less than 0.75 and less chances of R being greater than 0.75. So if R is less than 0.75, which is very likely, higher fitness competitor is declared as the winner. And if R is greater than 0.75, which is less likely, lower fitness competitor is declared as the winner. Therefore, the selection mechanism in general tends to select the fitter individuals for reproduction. But an element of probability ensures that both competitors have a chance. Eventually, it is a mix of genetic information from both fit and not so fit individuals that is carried forward to the next generation. However, since the probabilities are such that they bias the selection process towards the fitter individuals, the average fitness of the population tends to increase from generation to generation. I hope the concept of tournament selection with this is clear. The pseudocode for this is also pretty simple. Let us have a look at it. Tournament selection into bracket K comma P. It takes two inputs. Firstly, K, that's the number with which the random number will be compared, and P, which is the population. Now let I1 and I2 be any two individuals from the population P. Let R be any random number between 0 and 1. Now, if R is greater than K, check which individual is less fit and return that individual. If R is greater than K, check which individual is less fit and return that individual. Otherwise, if R is less than K, check which individual is fitter and return that individual. If R is less than K, check which individual is fitter and return that individual. Please take a minute or two and try to understand this pseudocode. I'm sure the concept is clear now. This concept can then be expanded to have a competition with larger tournament size, larger number of competitors. So instead of selecting just 2 competitors, you can select more than 2 individuals in the beginning and set a competition between every pair. Choose the winner in every pair based on tournament selection algorithm. Then set a competition between the pair of winners and so on to finally declare a winner. I hope the content that was covered in this video was clear. Let us now continue this discussion in the live Google Meet. See you there. Thank you.